I've been asked to make a video explaining the Internet of Things. What is it? Well, we all know about the Internet. It's the system that allows everybody to link one another easily around the world. And then there are things. If you connect these things to the Internet, then you have the Internet of Things. We thank you for your attention. Well, we've got to fill in another 3 minutes. We are all used to connecting our PCs, laptops, tablets and mobiles to the Internet. But what does connecting things mean? Well, in 2 words, it means remote control. Remote means not local to you. Remote means distance, and distance is what the Internet does very well. Control is the interesting bit, where you can influence something and have power over it. You may already be able to log into your home computer and use it over the Internet, as if you were sitting in front of it. Programs like Skype allow you to share desktops with friends over the Internet many, many miles away. There are plenty of other examples on the web, where you can, say, see live images and control the video camera you're using. In this example, you can actually control a model railway set in a different country. You probably have remote-controlled televisions and garage doors that you activate at the press of a button. Lights come on automatically when they detect movement. So what if we take this further and make a kettle, a coffee percolator and curtains remote-controlled? Wouldn't it be better to have the gas and electricity meters read without having to send in readings or have someone call round to read them? Well, yes, and all of that is possible today with remote control. Already on the market are burglar alarm systems that send you a text to your mobile and can even stream a live video of the thief rampaging your home. Other systems control your heating. I can put this tag on my dog's collar and plot where she is on a map on the Internet. The same thing can be done using this rear lamp on a bicycle. Fitted to a vehicle, this device also plots its location, but also allows me to turn off the engine and speak to the thief. All of these things are fine examples and available today, but they're not really the full Internet of Things. Internet of Things adds another element to remote control, and this is sensors with intelligence. What if even the very simplest things are fitted with sensors and intelligence? The sprinkler in the back garden does not just spray water. It is intelligent and understands how to collect information about the local weather. On its own, it can log into a local weather service and not waste water on the grass if it learns that it's going to rain tomorrow. It analyses the moisture in the soil. It then decides whether to spray or save water. It could also analyse the health of the grass and add missing nutrients to the water if necessary. For this to work, it would have to control the flow of water, know how to communicate with the weather service, understand how much water grass needs, and analyse the moisture and nutrients in the soil. Your refrigerator orders more milk than normal as it knows your visitors are arriving shortly and they consume gallons of the stuff. The refrigerator also knows the price of milk and all your favourite local shops and orders from the best supplier. It can scan the barcode on the products inside and keep a record to ensure the food isn't past its storage date. It could also invent recipes to use the older food more efficiently. What ideas do you have? What things would you convert? But we can go further. If your shirt is intelligent, it can monitor your health. It can monitor your blood pressure, your heart rate, temperature and other vital signs, and then call the doctor on your behalf if it sees that you're about to have a heart attack before it actually happens. It could then forward a copy of your medical history to the ambulance crew as they rush to save you. If machines making predictions seems far-fetched, Google has already demonstrated that it can predict the spread of worldwide strains of flu simply based upon the search information collected from its millions of users of its search engine. The search data appears on the web long before the real epidemic emerges in the real world. There's more good news, as all of these ideas become simpler and easier to implement as the cost of technology falls day by day. It has been claimed that if all of the information on the Internet were published in books, it could be piled up to a column that would reach to Pluto and back 90 times. There's over 4,000 exabytes of data and growing all the time. But it's not just stored data, it's real-time data, living details that change as it happens. Some of these have interesting web pages, such as this one that shows the current electricity supply in the UK. This one shows every lightning strike around the world. This one plots the position and details of commercial airliners. Although these are pretty sights for humans to watch, the data is also available for machines to understand. When humans share, it's called peer-to-peer. When machines share information, it's called M2M, or machine-to-machine. Our sprinkler earlier would use an M2M link. It's like a World Wide Web, but for machines. At the centre of a lot of this technology today is, surprise, surprise, the mobile phone. It's not just a telephone in the old sense, but we can send video too. It has several ways of detecting where you're located and even knows which way round your phone is orientated. In human terms, it could be described as having sight, its camera, hearing, its microphone, touch, the fingerprint reader and the touch-sensitive screen, and now even smell, as some phones may be fitted with gas analyzers. Again, the ability of mobile phones grows continuously while their price falls. We've not yet mentioned GPS, the global positioning system, as it's not related to the mobile phone or the internet. It's an entirely separate scheme. The United States, Russia and Europe all operate separate constellations of satellites that circulate around the world. These satellites transmit accurate time information that allows receivers to work out where in the world they are with an accuracy of about 3 meters. The GPS and phone data collected from a large number of people can be put to good use. It allows companies like Google to amalgamate this data and produce information. The information is used to, say, plot traffic conditions on their mapping system in real time. This is the Gibraltar flyover in Cardiff, and here we can see how the green lines show free flows of traffic, and yellow is slower and red is stationary. All of this data is taken from the movement of mobile phones. We can even see how traffic flow changes over each hour of each day of the week. You could use this information to plan your route, but intelligent systems, such as self-drive cars, could use this automatically to drive you to your destination via the fastest route, avoiding all of the traffic congestion. Expand this to coordinate and control all cars in a city, and traffic jams could become a thing of the past. Cardiff Bus already know where its buses are. It is fed to them using the mobile phone system. This information can be shown on the internet and now fed to the display at bus stops. On the bus, you can now use your phone to pay your fare. The data collected is turned into information that improves the management and efficiency, which should lower costs. Imagine the amount of data there is just collecting the location of mobile phones. It's huge. In fact, it now has the title, Big Data. Big data is very valuable. It's the reason why so many systems are free. The owners of the systems collect the data about us as we use the system. The data can be sold and analysed to produce valuable information. Did you know this is happening? Is it correct to monitor people in this way? Every website records every page looked at by every visitor. Are you happy with this? At school, there are 2 general ways of connecting any device to the internet. The first is using a cable via an Ethernet port. Here, a cable connects to a wall socket and the socket is connected to a router in your school. These cables tend to be limited in length, to less than 100 meters. That's why the network is called a LAN, or a local area network, local to you. All schools in Cardiff are connected by fibre optic cables to County Hall, down in Atlantic Wharf in the bay. Atlantic Wharf tends to be further away than 100 metres from any school, so the connections are classified as WAN, or wide area network. From County Hall, the data continues to the biggest WAN in the world, the Internet. The second method used in schools for Internet connection is used by netbooks, tablets, pads, and other portable devices. This is a wireless connection. The wireless connection is known as Wi-Fi. You may have seen this symbol. Wi-Fi works like this. Your school has a number of very low-power radio access points installed, small boxes mounted high up on walls. They normally have one or more short aerials on them like this. See if you can detect them. Your portable devices connect to the access points providing the strongest signal and can change as you move around the school. The Wi-Fi access points are connected by cable back to your school's router. It then shares the optical link back to County Hall. As Wi-Fi is very short-range technology, it is also part of your LAN. At home, you probably also have a router. In the same way as you do at school, you connect your devices directly using a cable or wirelessly using Wi-Fi. With the Raspberry Pi, you can either use a cable or plug in one of these small USB adapters to provide Wi-Fi access. The signal then travels off to your ISP supplier by telephone wire, cable connection, or best of all fibre optics to get to the Internet and the big wide world. Wi-Fi is impressive and pretty fast, but does have the limitation that signals are very low power and do not travel great distances. Wi-Fi does not like walls or wet trees, but with the right antenna can travel many miles. In 2001, we connected the island of Flatholm to the Internet using Wi-Fi. We used these large microwave dishes to focus the signal in one direction, over the water to Cardiff. Although these dishes appear to be made of chicken wire, they reflect radio signals. They amplify the radio signal in the same way a mirror in a bicycle lamp focuses the beam from a small light bulb. Even though this particular link was a long distance, Wi-Fi is generally considered to be part of your LAN. Another name for Wi-Fi is microwave radio. Your mobile phone or cell phone can also provide Internet access. At the end of 2015, over 90% of the Earth's land surface can now be reached by a mobile phone signal. It's just a pity that the other 10% seems to follow me around. The mobile is connected using thousands of low-power cellular base stations that look like this. The mobile signal spreads out from these antennas, and the link back to the network uses these dishes, which are just like the Wi-Fi dishes we used on Flatholm. Here are 10 in Cardiff. Can you work out where they are, or even see them in a couple of examples? Mobile radio communications is also clever, as it knows where you are and connects your phone using the best radio signal from the best antenna. If you move out of range with one cell, then it reroutes the call via another, more local antenna. This handover between cells as you move is carried on without you knowing. So, we have wires, both fibre optic cables, copper cables and mobile phones for longer distance communication, and fibre, copper and Wi-Fi for shorter distance communications. But there are even more technologies hidden away in open view that interconnect our connected world. Here are a few. You may have heard of Bluetooth. This is the logo for Bluetooth. Bluetooth is a very short-range signal, typically only used over a few meters. It can use an invisible light beam to send and receive signals, just like your TV remote control. You can actually see this invisible light if you use the camera on your phone or iPad to look at the end of your TV controller and press a button. Bluetooth can also use radio to transmit over very short ranges. At the moment, we can't see radio signals. They are invisible. Another very short-range radio signal is known as RFID. It has this sign and is used on contactless credit card systems. The card has to be very close to communicate. RFID is very cheap and very small. You can see a typical RFID device next to this grain of rice. You can sometimes find them in shoes and shirts. Have a look. Their small size allows them to be strapped onto bees to find out how they navigate. Manufacturers embed these small radio devices into every product on the production line. The device can store information about each individual item and track it. Minicars are smaller than bees, but in this excerpt from a current BBC television programme, you can see how each car on the production line is tracked.
So we know where the car is. This is called a transponder.
This thing here?
And it carries all the information for the car. We know exactly where the car is in the building with that transponder, exactly.
So you'll know that is Mrs. Smith's car. It's going to China. She wants it black. She wants a seat like this.
Yes.
Every single detail that she's asked for will be put onto that car.
This really is a restatement of manufacturing in the UK, where manufacturing has moved to. So it's no longer kind of oily rags and things like that.
Even the building is part of the technology drive. Every time a key part is fitted, tools send a Wi-Fi signal to McLaren's supercomputer so it knows what's going on.
That was me.
Yeah.
It's nice when everything's clean and new, isn't it?
Don't try and walk out without paying for higher priced items, as shops use these towers to detect shoplifters. They too are radio devices. You may also have seen these elements protecting library books. Passports and other documents also have electronic devices embedded in them. Pets can also be identified by having small RFID devices implanted just under their skin. It can be read by placing a scanner nearby. In the next section of this video, we will show you how to build your own device to control a thing and connect it to the internet for the whole world to use. Our video wouldn't be complete unless we showed you how to build your own thing and join the Internet of Things. A complete set of detailed instructions is given in a separate video. This is an overview to give a flavour of how easy it is using a Raspberry Pi and some free open source software. First, connect your Pi and power on. Ensure it's connected to the internet. Download and install the software. If all is worked, you should be able to switch to graphical mode and use the browser on the Pi to see this screen. The web page displays a diagram of this set of header pins on the Pi. Each pin can be switched to be an input or an output by clicking here on the web page. Inputs are used to connect to switches or buttons, and outputs send signals to, say, LED indicators. If a switch is changed, the screen changes like this. Clicking on an output pin causes the LED to turn on and off like this. The header is controlled via the browser screen. Once the Pi has been shown to work on its own, other machines on the network can connect to it. By entering the address of the Pi into their browser, they too can control the header pins. Depending on your school's internal network, you can also see the Pi from your portable devices in your school using Wi-Fi. If this does not work, it means the connection of the wired LAN to the Wi-Fi via the router has been blocked. This blockage is called a firewall and can be removed electronically. If this is too problematic to change, then you could insert a small Wi-Fi dongle into the Pi and connect the portable devices using that. Again, we have another video where this is explained more fully. A firewall that will not be changed is that one at County Hall. This is a security measure. It stops the users on the internet from seeing the Pis inside any school. It could be easier to take your project home and set it up from there. Again, we have a separate video that explains exactly what to do, but here are the simple steps. We saw before how your domestic router connects your home to the internet. By talking to the router, you can ask it to change some of its firewall settings. The idea is to put a hole in the protective firewall to allow users in the outside world to see through to the web interface on your Pi. The inputs and outputs on the header are then controlled over the web. You would have to include additional circuitry to control motors, pumps, and other mains-powered devices. In our example here, we've also connected a camera to the Pi so that you can view the effects of your changes over the web as they happen in real time. You can connect a whole range of other devices to your Pi. This is a basic building block for the Internet of Things. What ideas do you have? Pyramids are always good, and this one helps us to put things into context, no pun intended. At the base are the sensors, the switches, the pressure pads, temperature gauges, heart rate monitors. These sensors produce values known as data. On its own, data does not have any meaning until it's interpreted and understood. When data is understood and put in place, it becomes information. A mass of information causes us to become knowledgeable. The final state above this is wisdom. Something for you to think about. So far, we've looked at the huge advantages of connecting systems to the internet, but there are disadvantages. White knights are good internet users, black knights are bad. As we were putting this video together in late 2015, one of the big news stories is that some group have broken into TalkTalk computers and stolen user information. This serves as a reminder that the internet has its rogues. Some of these as young as 12 to 16 years of age. There's also discussion of how much information the government in a free country should legitimately monitor in order to fight terrorism. Would you like your information read or stolen? How would you feel if unauthorized individuals access private information about you? This is a satellite view of a factory in Iran. This is an Iranian center for the production of nuclear material. This factory came under attack, not by conventional weapons, but a cyber attack. It's now commonly accepted that an attack was launched by the Americans and Israeli governments on this plant to disrupt its production. News of this event was only published when a copy of the electronic infection broke out of the plant onto the web. It was detected by antivirus software companies, but initially nobody understood what it was or how it worked. It was strange for such an infection to sleep for so long. Luckily, it turned out that the infection was programmed only to attack production control computers and not standard PCs. For more information, search Stuxnet. A website published a list containing over 73,000 addresses of cameras connected to the internet. Anybody could log in and watch their content live on the video stream without the owner's knowledge. This occurred purely because the owners did not change the default password before installing the devices. The internet is a very dangerous place. In another video called Pi Honeypot, we demonstrate using a Pi connected to a domestic router and an open firewall that an attack is likely to happen within 15 minutes of connection. The attack may not be some human cracker, but an attack automated by another machine that's also infected. The infected machine tries to spread a copy of its own bad code onto other machines that then go on to attack further machines. It's like flu. That's why it's called a virus. Unlike flu, your infected machine may not show signs of having any virus. Little appears to happen. Some infected machines just do nothing but sit and listen. They continue to do nothing until a botnet master issues a command. This command could say attack a given site. A mass army of waiting machines receive the command and all wake up to follow the instructions. The poor site being attacked is then overwhelmed by infected machines from all over the world attacking it. It's called a distributed denial of service attack. The CIA, Sony and MasterCard have all suffered such attacks. There are currently estimated to be 4 billion people connected to the internet. In 2008, there were 4 billion things on the internet. Today, there are an estimated 12 billion things on the internet, and this is set to continue to explode in size. A new addressing scheme has been introduced that ensures that there's space for 78 billion things and people in total on the internet. Of course, the number of viruses, worms and bots are going to grow too. We have covered a lot of ground in this video. The Internet of Things was originally described as remote control of things over the Internet. We saw examples such as video camera control, burglar alarm systems, and the control of model railways. But the Internet of Things means far more than this. Things on the Internet don't just have remote control. They also have sensors with intelligence and methods of communication that make them more powerful and useful. We looked at a simple object like a lawn sprayer that could connect to the weather centre to prevent it from wasting water. As objects in the real world become more powerful, such as self-drive cars, so does the network that supports them, delivering a worldwide real-time resource of information and processing power. Imagine all driverless cars sharing information so that traffic queues were a thing of the past. With over 50% of the world's population, like us, living in cities, this could have a huge effect on our lives. What problems can you see and solve? We saw a range of communication systems and how schools and homes are currently connected and how powerful the mobile phone system is. We saw how to construct a simple example of a thing using a Raspberry Pi. What devices could you connect to this Pi? We are currently undergoing an explosion in technology, probably limited only by our imagination. Take part. It's been said that the best technology is that which operates unseen. We use it so often it just disappears into the backgrounds in our lives. What are these technologies? We looked at the privacy and security problems the explosion in the size of the internet will bring. There's only one thing that bothers me. What happens when it all goes wrong? Hello? Hello?